Good morning, my dear friends. I hope you all are doing great. So today, let us start our topic, which is isoelectric point, represented by Pi. What is this isoelectric point all about? Yesterday, we have spoken about Zivitar ion formation, correct? Zivitar ion will have a positive charge and negative charge. When we cancel plus and minus, the entire molecule, Zivitar ion molecule, will be electrically neutral. When Zivitar ion has a net zero charge, because one side it has a positive charge, one side it has a negative charge, plus will cancel the minus, total charge over Zivitar ion will be zero, so it's neutral. If Zivitar ion is neutral, if Zivitar ion is placed in an electric field, let's suppose I am a Zivitar ion, I have a positive charge and a negative charge, okay? Plus and minus will cancel, total charge is zero, okay? Understand, the net charge is zero, correct? This is plus, this is minus, correct? So I am a Zivitar ion. If you place me in an electric field, okay, but at a specific pH. So pH has to be specific, because every amino acid or every Zivitar ion will have its own pH at which it will neither move towards cathode nor anode. I am a Zivitar ion, okay? So I have a positive charge and negative charge. Because of my positive charge, I should move towards what? Cathode. Cathode should attract me. And because of my negative charge which I have, anode should attract me, okay? But I have plus as well as minus. So one side I will be attracted by cathode, my positive charge will be attracted by cathode. And this side I have negatively charged, so I will be attracted by anode. So I will be moving like this, like towards the cathode and towards the anode. And my net displacement will be zero, because I am being attracted on both sides. My positive charge is attracted by cathode in an electric field, and my negative charge is attracted by anode in an electric field. So whether I should move towards right, whether I should migrate towards cathode or I should migrate towards anode, which side I should migrate, okay? My net migration is zero. I don't migrate because I am being attracted on both sides, plus and minus like that, towards cathode and towards anode. So that's why I'm telling you, my dear friends, every amino acid will act as Zivitar ion. Every amino acid will act as Zivitar ion. It will neither migrate towards cathode nor it will migrate towards anode, okay? But at a specific pH. I hope you have understood this particular thing. Let me give an example here. If we talk about this particular molecule, COO minus and NH3 plus, and here we'll take R, correct? Now, if I place this Zivitar ion in an electric field, okay? Let me talk about, here we have anode with a positive charge, and here we have cathode with a negative charge. So this positive charge will be attracted by the cathode, okay, and this negative charge will be attracted by the anode. So what will happen? This Zivitar ion will not move anywhere because it is equally attracted on both sides. Right side as well as left side is equally attracted by cathode and anode. So the net movement of the Zivitar ion will be how much? Zero. And if we talk about that, we are telling that net charge over it is zero. Yes, net charge is also zero because plus 1 will cancel minus 1. So the net charge over Zivitar ion is zero. It will neither move towards cathode nor towards anode in an electric field. I hope you people have understood this factor. And the pH at which your Zivitar ion does not move towards anode or cathode in an electric field, that pH is known as basically the isoelectric point. Okay, so that is isoelectric point. And you know at which pH glycine reaches to the isoelectric point? Glycine reaches to the isoelectric point at pH 6. So I will tell you, at pH 6, almost 99.98% of glycine, okay, reach to isoelectric point. What is the meaning of reach to isoelectric point? Which means it becomes, zwitter ion. So if I remove this R and put here H, now this guy will become glycine. So this glycine at pH 6 will act as a zwitter ion. So glycine at pH 6 will act as zwitter ion. It will neither move towards cathode nor it will move towards anode. So the net migration will be 0. Okay? I hope everybody has understood. So let's revise it once again. At a specific pH, okay, an amino acid neither migrates towards cathode nor towards anode in an electric field. Why? Because the net charge over it is 0. Okay? And what is that isoelectric pH for the glycine amino acid? It is that pH is 6. At pH 6, our glycine amino acid will act as zwitter ion. It will neither move towards cathode nor it will move towards anode because the net charge over it will be 0. I hope you have understood the term isoelectric point. Thank you. So my dear friends, let's talk about few of the physical properties of amino acids. First of all, if we look at here, amino acids are colorless crystalline solids. Colorless means they don't have any color, okay? The second thing is that crystalline. Crystalline means they have a definite arrangement of atoms in their molecular structures. Okay? Well-defined arrangement of atoms, or we can say well-defined arrangement of molecules in their structures. So we call them as crystalline solids. They are soluble in water. So amino acids are water soluble, but they are slightly soluble in alcohol. So your amino acids are very, very less, soluble in alcohols, but they are highly soluble in water. And the final thing is that they have a high melting, point. Your amino acids have a high melting point because they are the crystalline solids, so their melting point is very high. And they behave like salts. Your amino acids behave like salts rather than simple amines and carboxylic acids. Because if you usually take an amino acid, you will find out an amino acid should either behave like a carboxylic acid or your amino acid should behave like as amines, because this is the amino group, and this is basic group, basic, and this guy is acidic group. So your amino acid, this is our amino acid. Our amino acid should behave like either carboxylic acid or it should behave like a amino group. That means it should behave like a amine. Let us call this NH2 group as amine group. It should behave like a amine. But my dear friends, your amino acid is neither behaving like carboxylic acid nor it is behaving like amine. Amine means NH2 group. These two groups are present in amino acid, but amino acid does not behave like carboxylic acids or it does not behave like amine, because this group is amine. Okay? So what I am going to do now is that I am telling you that the amino acid is behaving like salts. How does it behave like a salt? You have read last time, about the zither ion formation. That means this is acidic group and this guy is basic group. This is basic and this guy is acidic. So acidic group can react with base and basic group can react with acid. When acid and bases react, what they make? They make salts. So this carboxylic group can donate H plus. Last time I told you, it will donate H plus and it will change into CO minus. This NH2 group with a lone pair can accept H plus and it will change into NH3 plus. Correct? H and R. Now this is your zither ion. Here this guy has lost H plus. This was acidic group, it has lost H plus. Okay? So it has reacted with actually the basic group. This is basic group. It has accepted one H plus. That means it has reacted with acid. When there is a reaction between acid and base or base and acid, there is always the formation of salt. So you can take on this zither ion as a salt. Because it has both acidic group here and basic group. Acidic group can react with basic group and basic group can react with acidic group. Okay? The point here is that when acidic group reacts with a base to form a salt, when this reacts with an acid, it will also form a salt. So overall, your amino acids will behave like salts. I hope you have understood these physical properties of amino acids. So my dear friends, let us talk about proteins now. What is protein actually? Okay. So my dear friends, protein is basically a polypeptide. But there is a condition. With more than 100 amino acids. How many amino acids should be there? Amino acids should be there? There should be 100 amino acids or more than that. You should have more than 100 amino acids. Okay? In a polypeptide. And these amino acid residues, or you can say amino acid molecules, correct? Linked through peptide bonds. Okay? There should be a peptide bond between amino acids. Please focus right up here. So my dear friends, your protein is nothing but it's a polypeptide. Okay? But here the poly term here means actually more than 100. Here the poly term, if I tell you, in case of protein, here means, you can have a look here, more than 100 amino acids. So the term poly here is more than 100. Correct? And these amino acids residues are linked through which bond? There should be a peptide bond between them. Okay? And one more thing, having molecular mass, that means the molecular mass of protein should be how much? The molecular mass of protein. How much it should be? It should be higher than 10,000 units. Okay? And what is this? In place of this, you can also write down it as 10,000 atomic mass units. You can also write it as, let us suppose, 10,000 Daltons. dA you can write down or directly you can write down Daltons. 10,000 Daltons. Because atomic mass unit, or we can call it as unified mass. Unified mass, atomic mass units or Daltons, they are same. In place of 10,000 Daltons, you can also mention, let's suppose 10 K Dalton. What is that K Dalton here basically? It is nothing but 10 kilodalton. And that will be your 10,000 Daltons. So this much is not required here. Let's understand, my dear friends. Two things are very much important now in case of proteins, which you have to learn actually. First of all, you have to learn in proteins that the number of amino acids should be greater than 100. Should be more than 100 in a protein. Correct? Second factor is that molecular mass. Molecular mass of protein. Molecular mass of protein should be what? You can have higher than 10,000 unified mass or 10,000 atomic mass units. So it should be greater than 10,000 AMU. So these are the two factors. Protein. If we talk of protein, protein should have amino acids. How many amino acids should be in protein? More than 100. Second thing, molecular mass of protein should be greater than how much? 10,000 atomic mass units. Correct? And obviously the one more thing is there, in protein we have a peptide bonds. Okay? I'll say that peptide bonds will be present there. Peptide bonds are present between alpha amino acids. Alpha amino acids. So we will understand all these things when discussing about the protein structure. So my dear friends, what is a protein? Protein is a polypeptide and it contains more than 100 amino acids which are linked together through peptide bonds. And the molecular mass of protein has to be, it has to be greater than 10,000 atomic mass units. I hope you have understood what this protein is all about. We will discuss in detail the structure of a protein where you will get more information about peptide bonds, okay, and what is actually the polypeptide. So, but there is an exception to this particular theory or this particular definition. There is an exception, and that exception is insulin. Insulin is basically a protein and it's a hormone as well. What is the condition for a substance to be a protein? For any substance to be a protein, the amino acids should be greater than 100. For any substance to be a protein, the number of amino acids have to be greater than 100. But in case of an exceptional case called as insulin, it's a protein and hormone also, the number of amino acids in insulin are just 51. But that is also a protein. That means exceptional case is there. The exception to this definition. So I will write down here exceptional case. Please remember this exceptional case. Who is this exceptional case? That is our insulin. Insulin is basically a protein and it's also a hormone. Okay. And this insulin contains 51 amino acids. When we look at the definition of a protein, it should have, look here, more than 100 amino acids should be in a protein. But look here, I am telling you that insulin is a protein and it contains only 51 amino acids. So if I go for this definition, I need more than 100 amino acids to make a protein. But here I have only 51 amino acids. So according to this definition, it should not be a protein. Our insulin should not be a protein according to this definition. But insulin is a protein molecule. That means it's an exceptional case. So remember this exceptional case, that is insulin. Insulin is an exception to this particular definition. So we will be discussing this definition in detail. Please make note of this. And please remember, amino acids should be more than 100. And this is an exceptional case where amino acids are only 51. Second thing, molecular mass of protein should be greater than 10,000 AMU. And peptide bonds in protein should be present between amino acids. Please remember this thing. Make note of this so that we can discuss it one by one. So my dear friends, let us talk about first peptide bond. What peptide bond is all about, correct? Have a look. Let's take one amino acid, H. Let me open up this particular thing. This is our NH2. Okay, and here we have carboxylic group, that is C double bond O and OH, and here we have R group. Let me call it as R1. Means any side chain you can take. There are 20 R groups. That's why there are 20 different amino acids. This is a side chain, correct? So now let me call it as amino acid number 1 or amino acid 1. Correct. If I replace this R group by hydrogen, it will become glycine. But I am not doing that. I am just writing a general amino acid right out here. Let's suppose R1 is the side chain. Correct. Let me take one more amino acid here. H, C double bond O, OH. Then you have here NH2. And let me write down here R2. Let's suppose this side chain is different. So we'll get here amino acid second. Correct. So what is happening between two amino acids? Let us understand, because we are talking about peptide bond first of all. What happens? This is carboxylic group. Everybody knows this group is carboxylic group. It will give OH and this NH2 group will give H. Now have a look here, my dear friends. Carboxylic group gives OH and the NH2 group gives H. And this NH2 group, we know this is amino group. And this is basically the carboxylic group. So now, my dear friends, between two amino acids, there is a reaction between carboxylic group of one amino acid with the amino group of another amino acid. So they react with each other. And there will be a loss of H2O. What is that H2O? Water will be lost here. Minus H2O, water is lost. So now what will happen? Carboxylic group will react with the amino group. Carboxylic group of one amino acid will react with the amino group of another amino acid. Okay? It will result, okay, in the formation of peptide bond. It will result in the formation of peptide bond, and there will be also the loss of water molecule. You can see here, water molecule will be lost. So how the peptide bond will be formed? Have a look here. The peptide bond will be formed like this. If I remove this hydrogen now from here and OH from here, now these two groups can react. Carbon and nitrogen can react. Now this CONH, this CONH bond is called as, this bond is called as peptide bond. It is also known as amide bond. Why it is also called as amide bond? Because CONH group is called as amide group. CONH is called as amide. That's why it's also known as amide bond. I hope, my dear friends, you have understood what is peptide bond. So tell me, what is peptide bond? Peptide bond is basically a bond which is formed between carboxylic group of one amino acid with the amino group of another amino acid through the elimination of water molecule. So let us write down its definition, and also we will write down the structure. So don't worry. Okay, let us draw the structure only first. Have a look. Look here, my dear friends. So let's suppose we have H here, then we have NH2, and obviously it has a lone pair. Everybody should know that. C double bond O, then we have OH here, and then we have R1. Let's call it as amino acid 1. Okay? Let's take another amino acid here. C, H, C double bond O, then OH. Then finally I will write down here N, H and H. And even it has a lone pair. Okay? So don't worry. So what I am going to do, carboxylic group, I told you just now, this is carboxylic group of one amino acid. And this is basically the amino group, NH2 group. So OH from here and H from here will be lost. So there is a loss of water molecule. Okay. So carboxylic group is reacting with amino group. There is a loss of water molecule. Now there is a formation of peptide bond. Have a look here now. You have now NH2. Cool. Then you have C, H. Then you have R1. Okay, here I have to put actually R2. And this is our amino acid number 2, correct? That is the side chain. Everybody knows about this is a side chain and side chain. Cool. So after that, what happens? What is left here? CO is here, and what is here now? NH. This and this is lost. What remains here? CO, C double bond O. What remains here? NH. So there is a bond now, CO, NH bond is here now. After that, let's go further and write down CH. Then you have here R2. And here you have now C double bond O and OH. Now my dear friends, this particular bond is CONH bond, and this CONH bond is basically called as peptide bond. That's a peptide bond. And this peptide bond is also known as amide bond. Okay, and you know that how many amino acids are reacting here? 2 amino acids are reacting with each other. So 2 amino acids are basically called as dipeptide. Don't think that dipeptide means 2 peptide bonds. Dipeptide means basically the molecule containing 2 amino acids is known as dipeptide. Peptide basically means, if I talk of peptide bond is between carboxylic group and amino group, correct? But when I talk of dipeptide, don't take this dipeptide as peptide bond. Dipeptide is a separate thing. So I will write down here, this is known as dipeptide. Why dipeptide? Because it contains 2 amino acids. So how many amino acids are present here? R1 and R2. These are 2 amino acids here. So we call it as dipeptide. This dipeptide and this is different. This is peptide bond, and here the dipeptide means it contains 2 amino acids. Okay? So what is dipeptide? A molecule containing 2 amino acids is dipeptide. So now you have understood one thing. In this dipeptide, how many peptide bonds are there? 1. So we have 1 peptide bond. This is dipeptide. It's made up of 2 amino acids, correct? Okay? So look, amino acid 1 and amino acid 2. So it's called as dipeptide. And between these 2 amino acids, how many peptide bonds are there? Just one. Only 1 peptide bond is there. And this peptide bond is nothing but it is CONH bond. CONH bond is known as peptide bond. Remember, for competitive exams, CONH bond is known as peptide bond. So dipeptide will have 1 peptide bond. It contains 2 amino acids and 1 peptide bond. Because between 2 amino acids you will have only 1 peptide bond. Correct? So now let us write down the definition of peptide bond. You have understood this thing, my dear friends? So peptide bond is formed between carboxylic group of 1 amino acid with amino group of another amino acid. The bond formed between a carboxylic group of 1 amino acid with amino group of other amino acid through elimination of water. So water is removed here, my dear friends. So what is removed here? Water. You can have a look. The water is removed here. This water can be shown here also. You can mention it as minus H2O. So water is lost here. So I hope you have understood this particular thing. How many amino acids are participating? 2 amino acids. So that's why it's called as dipeptide. Dipeptide means in which 2 amino acids are reacting. Correct? That's a dipeptide. And in dipeptide, how many peptide bonds are there? 1. So remember that particular point. Please make note of this. So my dear friends, we have spoken about the peptide bond. It's a bond formed between carboxylic group of 1 amino acid with the amino group of another amino acid through the elimination of water molecule. And you know that peptide bond is also known as amide bond, okay, or it's also can be called as C double bond ONH bond or CONH bond, it can be called as, correct? Now look here, if we talk of dipeptides, dipeptide does not mean it has 2 peptide bonds. Dipeptide basically means the number of amino acids represented by N. How many amino acids are in dipeptide? There are 2 amino acids or amino acids in dipeptide. But between 2 amino acids, how many peptide bonds will be there? N minus 1. How much is N? 2. 2 minus 1 is how much? 1. So N minus 1 will be number of peptide bonds. If you have a tripeptide, remember, tripeptide will have how many amino acids? 3. And how many peptide bonds will be there? Peptide bonds will be N minus 1. What is N? 3. 3 minus 1 is how much? 2. So 2 peptide bonds will be there. Tetrapeptide means 4 amino acids. Penta means 5. Hexa means 6. And poly means actually more than 10. Okay? Poly means more than 10. Okay. Now, when it is more than 10, the same poly, please try to understand, same polypeptide, when it is more than 100, at that time this polypeptide will be called as protein. But this polypeptide is not a protein. This polypeptide is not a protein because here we are saying that more than 10. More than 10 basically means it can be anything. It can be 11 also, 12 also, 13 also. But when we say polypeptide more than 100, here also it can be 1000 also, but it is not specific value. Here we are talking about more than 100 only. If more than 100 are there, obviously at that time I can use the term protein. So polypeptide will become protein. Let us suppose this is greater than 10, basically means it's 11. So it's a polypeptide. If it is 12, still it's a polypeptide. If it is now, let us suppose 101, more than 10 is, let's suppose 101, then this polypeptide will also become protein. I hope you have understood, my dear friends. So let's talk about it later. Now if we say here 6 amino acids are here, so this will be N minus 1. Okay, 6 minus 1, what is that? 5. So obviously here will be 3, here will be 4, and here will be 5. In competitive exams, they have asked once, in octapeptide, how many amino acids are there in octapeptide? It's easy, there are 8 amino acids, but they have asked how many peptide bonds are there. In octapeptide, amino acids are how many? 8. Yes, but how many peptide bonds are there? N minus 1. Okay, what is that? 8 minus 1, how much is that? 7. I hope you have understood. If you have 1000 amino acids, then how many peptide bonds will be there? 1000 minus 1, how much is that? 999 peptide bonds will be there. I hope everybody among you has understood. Now if I will write down here polypeptide, but that polypeptide can have more than 10 amino acids, but that won't be considered as protein until and unless that polypeptide will have more than 100 amino acids in its structure. I hope you are understanding. Please remember this particular point. The number of amino acids and number of peptide bonds. My dear friends, if my polypeptide is a protein molecule, remember, if it is a protein, if it is not protein, let us suppose if polypeptide is not a protein, at that time you can tell that amino acids should be greater than 10. That you can write down. But when you say that your polypeptide is a protein, at that time the N value, do you know what is N? Just now I told you, number of amino acids, okay, should be greater than 100. Okay, so I will tell here this term means, okay, number of amino acids are greater than 100. N stands for number of amino acids. So they are greater than 100. So it will be now called as protein. If this N is, let us suppose if I write down N is less than 100, then I have to remove this thing. Then it will be a polypeptide. It won't be a protein. So condition is there. And exceptional case also you remembered, insulin. Insulin is the only exception case. Okay? So it is a protein. We know that N is greater than 100. Correct? Let us fix up some value. Let us suppose if N is, let us suppose 1000. That means how many amino acids are present in a protein here? Let's suppose 1000 are there. Then how many peptide bonds will be there? N minus 1. What is that? 1000 minus 1. How much is that? 999 peptide bonds will be there. If your number of amino acids in a polypeptide are 1000, then N minus 1 means number of peptide bonds. How many peptide bonds will be there? So N minus 1 basically means number of peptide bonds. This term means number of peptide bonds will be 1000 minus 1. How much is that? 999. That's quite common thing. So let us draw a structure. Have a look here. I will take one amino acid here. H. Let's suppose R1. Side chain is R1. C double bond O and OH. Then finally I will write down here NH2. It has a lone pair, don't forget that. So let me write down one more. Let's suppose H, C double bond O and OH, and here we have N, H, H, and here let's write R2. Let's suppose this is amino acid 1, this is amino acid 2. Let's talk about the third one. H, N, H. Then you have here C double bond O, OH. Then finally you have, let's suppose R3. Then this is amino acid third. So third amino acid it is. Now look here, my dear friends. Everybody knows that there will be a loss of water molecule here. Loss of water molecule, loss of water molecule. So two water molecules will be lost, H2O and H2O. Two water molecules will be lost. Now what is my point? How many amino acids I am taking? 1, 2, 3 amino acids I am taking, correct? When I am taking 3 amino acids, how many peptide, what is N value? N value is 3. Number of amino acids are 3, that's N value is 3. How many peptide bonds will be there? N minus 1, 3 minus 1, what is that? 2 peptide bonds. But I am not talking about, see here, how many amino acids are here? 3. 3 amino acids means tripeptide. Tripeptide. Okay, and tripeptide will have 2 peptide bonds, correct? But my topic is polypeptide. Here the N value is greater than 100. But I have written only 3 amino acids. I have written only 3 amino acids. So what I am going to do, have a look. Please look here. After the removal of water, H2O, can I remove it directly now? So I will remove this and I know what is the peptide bond. CONH bond is the peptide bond. This. Now this is my peptide bond. CONH bond is peptide bond. Let us remove this water molecule from here. My dear friends, CONH bond is the peptide bond here. Have a look. This is the peptide bond here. Now after that what happens? From this side the chain does not grow on this side. Okay? What does NH2 group provide us? NH2 group will provide us hydrogen. That we should know. And carboxylic group will provide us OH. You have seen it. NH2 group can give hydrogen and carboxylic group gives OH. That you have seen just now. Okay. What happens on this side? Have a look here. On this side I will remove the hydrogen and I will do the capping of the molecule. Like this side I will block it. This side is blocked. So that it should not grow on this side. Protein should not grow on this side. It is being capped here. We do capping here for the protein or protein is being blocked here. But carboxylic group is always ready. COOH is always ready to give OH. So it will give its OH to another molecule like this. You have NH2 here. So this OH and H will go to make H2O. Because you have here now H, R, let's suppose 4 and COOH like this. So water will be lost here. So again CONH bond will be formed. Means a peptide bond will be formed like this. But I can't show so many amino acids, because if I keep on writing, I have to write down more than 100 amino acids. I have to write down more than 100 amino acids. So I can't write down more than 100 amino acids here. So what I am doing actually, I will cut this part and I will tell you that which group it has, OH. This OH will react with the hydrogen of another amino acid like this. So this OH will be also removed, because when you remove this OH from here, you are making us understand that this chain will continue from this side. So it will continue from this side. But how many times it will continue? N times it will continue. And this N value has to be greater than 100. This N value has to be greater than 100. I hope you have understood, my dear friends. This N value I am talking about, N. This N should be greater than 100. And the molecular mass of this substance, this now, because I am taking N how much? Greater than 100 I am taking N. So the molecular mass of this particular substance should be greater than 10,000 unified mass, or greater than 10,000 Daltons, or greater than 10,000 atomic mass units. So I have already told you that molecular mass should be also greater than 10,000 units, or we can say Daltons. Okay? So my dear friends, I hope you have understood this thing, and this entire molecule is nothing but a polypeptide, obviously. But this polypeptide contains N, and this N is basically greater than 100. If we think this is greater than 100, then this polypeptide will become a protein. I hope, my dear friends, you have understood now that this is the protein structure. And you know what is the exceptional case for the protein? Exceptional case is insulin. Because I am saying that N value should be greater than 100, but in insulin N value is less than 100. Only 51 amino acids are there in insulin. So remember that exceptional case also. I hope you have understood, my dear friends. So this is your polypeptide. And how many peptide bonds will be in this polypeptide? If N value, let us suppose, is greater than 100, greater than 100 means what? If it is, let us suppose, 200, the peptide bonds will be how many? Amino acids are 200, peptide bonds will be 200 minus 1. How much is that? 199 will be the peptide bonds. Please remember that thing. So, please make note of this. So my dear friends, now you have seen here, this CONH bond is your peptide bond. This is your peptide bond, and here again, this CONH bond is your peptide bond. So these are the peptide bonds. Remember, peptide bond is CONH bond is peptide bond. And this peptide bond is also known as amide. Amide bond. You know why amide bond? Because you know the formula of amide. CONH2 is amide. Okay? It's a functional group, amide. Now look here, it is CONH. It's not exactly CONH2, but at least CONH is there. And CONH will be also called as amide. So that's why it's called as amide bond. This CONH2 is actually known as acid amide. So if you look here at acid amide and if you look here at this bond CONH, they are almost same. That's why CONH bond is called as also amide bond. And you can also write down the CONH bond also. So I hope you have understood, my dear friends. Tomorrow we'll be discussing about the fibrous proteins, global proteins, and the various structures of the protein like primary, secondary, tertiary, and quaternary. Do take care of yourself. Yo-yo.